Good morning. Welcome to another session on environmental impact assessment.
So let us begin Unit 5, Case Studies. Course outcome: describe the EIA for various infrastructure projects. Learning outcome: explain the EIA for railway project. Specific outcomes: explain the impacts of railway operation on the environment. Scope: the sector of railways and railway operation encompasses the construction of railway lines and systems as well as actual railway operation. The railway sector is strongly characterized by its economic environment. Its aim is to provide transport services by rail, making use of relevant resources. Its efficiency depends on the resources used, the manner in which they are employed, and the infrastructure of fixed location facilities. Various kinds of tractive power are used, mainly diesel locomotives. The types of wagons and loading facilities and the operations management depend on the volume of passengers and goods carried. For the transport of hazardous materials, special requirements must be met in order to avoid the risk of environmental damage. To a greater extent than other sectors such as agriculture or foodstuff industry, railways largely use standard technologies so that the potential environmental effects and the means of avoiding them are largely similar. Railways generally have their own comprehensive infrastructures, normally encompassing all rolling stock and track. They undertake tasks which are also performed by commercial operators such as engine maintenance works. Railways are generally run by government, although other companies are often responsible for monitoring observance of government regulations. Environmental impacts. Railway construction and operation have unavoidable effects on the environment, such as incursions into the landscape or emission of exhaust gases and noise. Other effects such as emission of pollutants in workshop areas and in the event of accidents depend largely on the equipment and the care with which work is carried out. So overview of the impacts. Environmental impacts in the case of railways and railway operations are derived from one, planning and implementation of the infrastructure, especially on the track. The characteristic features of the rolling stock used, that is traction method, age and condition, technical standards and safety of the equipment. The operation condition of the track and fixed location installations, right? So depending on the condition of the track, signal systems, stations, marshalling yards, workshops. Operations management, including the qualification of the person or the personnel who is working there and the maintenance measures. In this context, awareness of environmental problems on the part of the management and workforce is crucially important. That is, the nature and handling and risk potential of the goods being transported, the volume of passengers and freight, and the resulting degree of utilization. So let us see the impacts one by one for different operations. So fixed track installations and track layouts. So this actually means the installation of the railway tracks, right? So I'm sure you might have come across at least somewhere in some railway station, or maybe in some videos you might have seen how they lay the railway tracks, right? So that is a process, and we will see the effect of that process on the environment. So first is the effect on the soil. Due to the space with which they occupy, railway tracks may cause valuable areas of land to be taken up. There is loss of agricultural land or biotope. Some lines are laid through rainforests, and different types of forest areas are being covered, etc. Lines intersect residential areas and may initiate economic activities which lead to the destruction of natural resources, such as a background effect or consequence. Right? For example, establishment of charcoal-fired blast furnaces along a line, construction or utilization of a line for transport of tropical timber, etc. When railway lines or systems are constructed, earth is displaced. Embankments need to be built, for example, and the earth required for this is derived from elsewhere. The spoil from tunnel construction needs to be disposed of in an environmentally acceptable way. That is, meaning you are digging a tunnel for the railway line. So in that case, a lot of earth materials are excavated, or not excavated, meaning you are constructing a tunnel through maybe some rocky areas. So in that case, a lot of rock material is being uh, removed. So those things have to be disposed of in an acceptable way if it cannot be used for embankment construction, right? If you cannot use that and make some, some sort of embankment is some sort of small you know, culverts that are being constructed. So if that is not possible, you have to dispose them in a proper way. The same applies to the construction of lines and cuttings. Right? When the soil is exposed, there is a risk of erosion. In the area of railway installations, such stations, surface construction causes the ground to become sealed and compacted. Second is the surface water problem, both on embankments and more particularly in cuttings. Actually, the embankment is actually filling up. Right? You have cutting and you have filling up. So when you excavate some of the soil you are cutting, so that soil has to be, you can use it for filling up somewhere else, right? The filling up can be above the surface of the land also, right? So that is the embankment. So more particularly in cuttings which often have considerable water discharge areas above them, care must be taken to ensure effective methods of lateral water drainage. Water courses rerouted if necessary must be large enough to lead the surface water away effectively. Recultivation and replanting are needed to combat erosion due to rainwater and landslide. Even if railways, unlike other transport systems, do not seal the surface, right? Even in railways, even in railways, unlike other transport systems, do not seal the surface so that rainwater is still able to soak away. It must be assumed that errors in layout and design will cause water pooling and consequent damage. Streams and other water collection points may be polluted unless they are screened against the ingress of surface water. Next one is exhaust gas emissions. The incidence of exhaust gas depends on the first instance on the type of traction involved. Electric locomotives do not themselves produce any exhaust gases, that you know that, right? So the effect of power generation are not dealt with here, right? Steam locomotives will not be considered here either because they are being now very rare. Essential pollutants in exhaust gas from diesel engines are carbon monoxide, hydrocarbons, nitrogen oxides, sulfur dioxide, and particle emissions, that is soot. There is very very fine particles, particulate matters that are being emitted, right? You have something like a very black smoke sort of thing which you might have seen in some railway stations, that is being emitted from the exhaust. The extent of emissions from diesel engine depends essentially on these factors: the load and speed of the engine. The load depends in turn on the weight of the train and the speed of travel, which in most cases is determined by the track, right? So you have the combustion processes, operational processes, this 2-stroke or 4-stroke, standard of maintenance, and quality of fuel that is being used. As regards the degree of utilization, trains may be underutilized or they may be loaded to the limit of their capacity. So the causes of underutilization: too few passengers, that is very less passengers on the passenger trains; goods trains traveling with too little freight, meaning too little goods. Because the number of wagons in this case is also low, the weight with which it is being transported to no purpose remains limited to the relevant proportion of the locomotive's weight. Slow traveling speeds because of the condition of the track. Travel resistance which the locomotive is required to overcome drops at lower speeds. The causes of locomotives being loaded to the limit of their capacity are: your coupling loads are exceeded, long gradients, and shortage of locomotives. These are some reasons why they are loaded to the limit, to the maximum capacity, and the above reasons are reasons why they are underutilized. The major lubricants that are being used: so engine oil in combustion engines, viscous oil in gearboxes, drive systems and axle bearings, hydraulic oil in track machinery, axle drives, and hydraulic gears. Oil consumption in engines contributes to exhaust gas emissions but is less than 0.5% of the fuel consumption. Another factor which likewise cannot be avoided is the emission of lubricating oil from locomotives with the link or chain drives, which can lead to contamination of soil, groundwater, and surface water. So when they release these lubricating oils into the ground surface, they can contaminate the soil, or they can penetrate into the soil and reach the shallow groundwater, or they may even add up into the surface water bodies like ponds and lakes which are nearby. So these types of drives are obsolete and should no longer be used when new equipment is procured. When procuring any kind of oil, care should be taken to ensure that they are free from polychloride biphenyl compounds. These produce highly poisonous dioxins on combustion. Another major environmental pollution is the disposal of these waste oil, like what we uh, discussed, right? So disposing of this waste oil is another big challenge. The aim of establishing a regulatory system for dealing with used oil is to transfer recyclable used oil to a processing point, laying down appropriate conditions, such as the pollutant content or the products to be recovered separately or the bans on mixing, etc., and thereby minimizing the proportion of waste oil which cannot be processed and therefore requiring uh, costly disposal. On one hand, this ensures that most environment-friendly possible method of disposal. On the other hand, it helps keep the cost down. Waste oil of different types and containing different pollutants should, as far as possible, be collected and led away for processing or disposal separately. Basically, there are three groups of waste oil. Waste oil group 1 is the waste oil whose composition and place of origin are such that they are suitable for recycling. Waste oil group 2, these oils which can be used for energy production. Waste oil 3, which require disposal or refuse. Right, so they are classifying oils into different groups based on how they can be utilized after using them in the railway engines. Rehabilitation of oil contaminated ground. There are well-established processes for rehabilitation of ground which has been contaminated by oil and other certain kind of chemicals. Specifically, kinds of bacteria are applied to the contaminated ground which feed on the oil and the chemicals in the soil. Clay soils can be cleaned to the depth of 1 meter and sandy soil to the depth of 2 meters by applying the bacteria to the surface with additional nutrients if needed. Cleaning is more difficult at greater depths where it is necessary to introduce atmospheric oxygen. High ambient temperatures are ideal for biological cleaning. The bacteria are active at temperatures of 10 degrees and above. The extent of the damage must be established by test bores and monitored throughout the cleaning process. Alternatively, the soil can be removed and incinerated after the pollutant content has been assessed using special incineration systems. That is, you are burning them. Right? It may be possible to use the residue in road construction projects. Solvents. Solvents mostly involve halogenated hydrocarbons. Used solvents must be stored separately according to the main component of the initial product. These substances must not be used for normal cleaning purposes. As far as possible, substitutes should be used for that purpose. Every effort should be made to ensure that the solvents are recovered by the supplier. If this proves impossible, they should not be disposed of other than as special waste. Wood preservatives. If impregnated wood is used at all, example for sleepers, in some cases you might have seen some wooden sleepers or wooden rails that are used, right? Meaning not wooden rails. The rails are laid on wooden sleepers. That is, you might have, when you see the railway track, you see the rails, right? Steel rails. So you might have seen that there are some blocks that are placed right perpendicular to the rails at equal intervals. So those are sometimes made of wooden pieces, right? So if wood is used for such kind of purposes, any residues must be disposed of in special incineration plants, which may be for example be connected to the power stations. Impregnation agents with minimal environmental impact are to be preferred. Take special care with wood preservatives containing PCPs. Right, the wood can get contaminated and decay over time. So special care should be taken to provide some wood preservatives. Scrap. Before recycling scrap, care must be taken to ensure that any environmentally harmful substances have been eliminated in the proper manner, such as waste oil, coolant residues in lathe turnings. During the scrapping process, hazardous substances such as heavy metals must be removed and disposed of in the least environmentally harmful way. Right, so we'll continue from here in the next half. Right, thank you.
Thus, we come to the end of this session. Thank you for your participation. Looking forward to meeting you in the next session.